It is finally here. It took 10 days for this to come from New Jersey. I don't know why I couldn't find a place in California that sells it, but this is what I've been waiting for. The buzzer, it comes with this cable, and I added the JST connector so that we can connect it to the servo port in the little Fokker. All VESCs have such a servo port, at least all VESCs that I've ever seen. We hooked this up, and then I like to use hot glue or something to glue it down here on the side. So it'll be something like this here. That way it won't bounce around in there. By the way, the Bluetooth module, because it's in this shrink wrap and it's really light, I don't intend to fasten it inside the housing. So with the wires and everything, it can't really move much. It'll probably vibrate a little bit, but I see no reason to glue it down or something. Now that I have everything hooked up, let's take a closer look at the wiring. So basically, I'm using almost all the connectors now because of my Bluetooth module. You can see this one is right here with the 7-pin connector. Then I'm also using this 6-pin connector right there, and I'm using that to control the LED on the switch. Then right here is the ADC connector, and this one is actually really cool. That's unique compared to all the other VESCs, because the ADCs normally tend to be just in the 7-pin connector here, but the little Fokker has the 3-pin connector just for the foot sensors, meaning that the foot sensors go directly into the 3-pin connector and you don't need anything else. We have the obvious Hall sensor connector that goes in here. The last one that you see is this one here. Oh, and that's my buzzer. So that's the 3-pin servo connector that hooks up to the buzzer. And then the only thing that I don't have on this VESC is over here in the corner. You normally would have the power switch connected, but because I am using the momentary switch going to the going straight to the BMS, I only have connected it right here with that blue wire. Those pins that are sticking out right there, they do look scary, and they look like they're going to touch the aluminum plate that goes on top. I verified and I bent them back a little bit. They cannot touch, but still freaks me out. I'm going to put some tape on top of it to make sure nothing ever happens, no matter how much because seems scary, right? You do like some big drop and then do these things vibrate or not? I don't know. But can't hurt to put some tape over it. So yeah, that is all. Now we have to route all the wires through here. So basically we have this channel that the thick wires, the battery wire, needs to go through. And also we got to make sure that we don't pinch any of the thin wires. But there is a little bit of space between the holes for the MOSFETs. So it should be pretty straightforward, but it's a lot of wires. It's kind of tricky. You got to kind of push them through and just be very careful when putting it all down that nothing is pinched. Now, one last check I want to do before turning it on. I want to make sure it all works. So you see the green LED, and one thing I have changed in the firmware now is that I'm controlling this LED over the button, the GPIO pin called PB12. You can see it on the schematic, on the pinout, and that is freely controllable. So I'm actually using this button now to do some messaging. So right now it's telling me this blink every 2 seconds tells me I'm in the UART app, which means you won't be able to ride your board. And now let's go and connect to the VESC in the tool. So I've got an iPad here, so we'll connect to it. And now when I switch to the balance app and write the settings, so in the balance app you can see the LED kind of pulsing like that. So now you know you're in the balance app. And then when you're riding, I'm turning the brightness down of the LED. I find it annoying when they're super bright. But when you're stopping, you get this pulsing, and that way you know that your board is ready. And I'll probably add some more LED blinky features just for diagnostics, like for example, battery level warnings and these kinds of things could be shown through that LED. But yeah, that's what's cool about having those additional pins exposed. Most VESCs don't do that, but the little Fokkers and the cheap Fokker also had that, but the V3 of the little Fokker now has it, and why not use it? So now you can see it's halfway pushed down, but it gets tricky because you gotta now pull this battery wire out of place, or you gotta pull the battery wire to get out of the way so that you can push this down, because naturally it just does not want to go down. It feels like it's locked in right there. So you gotta keep moving these wires until they give way for the VESC to sit there. So this is what it looks like underneath, making sure that we don't pinch anything. All right, we're getting closer. It was one of the phase wires that was in the way. Now this is pretty much ready to go. Time for the lid to be applied. Well, need my tape. I found me some tape to put up there. That should be good enough. Once the lid is on there, there should be no way for that to come off. And yep, let's put that lid on. This time I am remembering to put the gasket on too. Lining up every single hole on the gasket is a huge challenge, but yeah, I spent about 5 minutes trying to line it all up. I think I'm gonna go with it the way it is now. So I am holding it down now with my hand, but some of the holes really don't line up, so I'm going to try my best to get them to line up before I bolt it down. But otherwise, I'm just gonna screw right through the gasket. I don't care. Now I still have to figure out which bolts go where. If anyone can manage to put the wrong bolts in the wrong place, that would be me. So I'm gonna guess the wood screws go straight into the PLA on the sides, and then the machine screws go here at the end. I have no idea what the big bolts are for. Well, let's put the little ones in. All right, it was more straightforward than I thought. This is the last one. And feels good. Looks nice and solid. Now we are good to go. I didn't plan on filming the assembly because it's pretty much like any other OneWheel XR, but I do want to show you guys how nice this cover for the connectors is. It is way better than the original design. It snaps in right here. At first I thought it didn't fit, but then it just, boom, snapped in, and it's super solid. I don't have to worry about it coming out of alignment when I put my bumpers on. It just fits so nicely. Really impressive work. Good job, Flowrider. Oh, Flow Glider. Sorry. Just to give you another look of the inside of that cover for all the connectors. Super impressive. Really cool. By the way, I had no reason to worry about those stop nuts. Fits perfectly. Assembly is completed. So we got our board on the bench, and let's turn it on. Now I will connect over Bluetooth. Connection worked, and firmware is already loaded. This is the stable firmware. Now we will load the motor configuration. And we will load the app configuration. Now, I've only loaded those files into the VESC tool. They're not yet on our controller. So to do that, we got to take the right motor configuration button here. Do that. Always look for the green write OK in the lower right corner. And we're going to do the same with the application. When we do the application right, we should also expect the button to change color. Well, same color, just different pattern. So now we know that we're in balanced state, and technically we should be able to just start writing. So I didn't do any kind of detection, no Hall sensors, no IMU, and let's see what happens when I... Okay, before we do this, a lot of you guys seem to want, and understandably want, to test this on the bench. If you want to do it on the bench, set P to 1, I and D to 0, and then also in your faults, make sure that it turns off quickly. 10 milliseconds, 50 milliseconds, something like that. So now we write that. Okay. And now, when I put pressure on the foot pads, the wheel should turn. Nope. Believe it or not, I managed to swap the Hall sensor connector and the foot sensor connector. That is why it wasn't working. So I didn't swap it here, I swapped it inside the controller box. So I had to take it all apart, wasted an hour and a half of my life. But here we are, back on the stand. Now, I did try those default settings, or basically VESCmann settings, and I realized I do need to run the motor detection myself. Here is what I'm getting. This clicking is not good. So let's go and run the motor wizard like we should. So we're connected to the board and we are in the balance app. I'm going to switch to the UART app just in case. I don't know if it makes a difference, but I have never run the wizard in the balance app. Okay, we can see by the blinking of the power button that we're in the UART app, so that switch worked. Now we go to Welcome and Wizards. We click on Setup Motors FOC. We do not need to load default parameters. Now we select EUC. We hit Next. Large outrunner, 2,000 grams. Here we're going to override sensorless. You know what, let's put it to 2,000 right away. Motor poles, 30. Yes, I'm sure. And battery, here we got 15. Capacity 6 amp hours. I think that's right for the stock XR battery, but it doesn't, the capacity doesn't really matter here. And advanced, I want, because we know our BMS will let us do 30 and minus 30. Actually, I don't know if they let us do minus 30, but I assume they do. Now, gear drive, wheel diameter on an XR is more like 285, and motor poles 30. Good. Run detection. Don't have CAN bus, and okay. Now we can see the motor turning. Make some noise, that's fine. And now the last step, I think, is the Hall sensor detection. And I believe that's one of the reasons why it doesn't work. The Hall sensor detection really is different from motor to motor, or from VESC to VESC with motor. Yeah. Alright, what do we have here? Motor current R85, L198, flux linkage 27. If I'm not mistaken, this looks good. Now, I'm not going to do this. So remember, when you run the motor wizard, it does automatically write the settings to your VESC, so you don't have to write settings right now. But we do want to make some changes, and I believe in general current, yeah, we definitely want a lot more than that. Just add a 1 here. Actually, I prefer 120. Positive and negative, and then absolute maximum needs to be 180 or higher. You always want about 35% more than what you have, or I would even go 50% more than what you have in the currents. Slow apps, current, yeah, sure. Battery current, min, max. Didn't I say 30? Alright, we can ignore that. Now we go to voltage. Here I want, no, I definitely want it to end at 2.5, so that's 37.5, and I want it to start at about 2.8. I think if I do that at about 40, I'll be good. Remember, we never want to even hit this because we have low voltage tilt back. Also, we have a BMS that will probably cut us off before that, so. And all the other stuff stays. Temperature, MOSFET, temp cutoff start. So here we could definitely handle 80 and 90. Not that I believe that we'll ever hit it, but here for the motor we get 85. Fine. And advanced, yeah, NTC 10K, 3900, that looks good. Alright, now we go to the FOC section here. We do need to cut the observer gain in half. It doesn't have to be quite half. I like something in the 0.75 territory. That's usually, it's always worked out for me. And don't ask me why. That's just how it is. Nobody knows why. Interpolation, this is all still good. Do not take the default of 500. It should be 200 for Hall interpolation. Then the rest I think we can ignore. And I believe that's all we need. So we'll write that. Alright, and while we're at it, let's also do the Imu calibration. So we'll go to detect and we'll let it do its thing. Obviously it's important that now the board is level when you do this, and the result has been received. And once you've done the calibration, there is 2 steps to get this transferred to your VESC. First, you hit apply. That copies the numbers up here. Oh. Why is all the rotation, roll, pitch, yaw 0? That is really odd. Can we do this again? All perfect 0, huh? Alright, I'll roll with it. I wonder if these numbers here, the crazy high KP, has an impact on detection. Let me just see this here. So this is a more normal number, 0.3. And we'll run, let's write that. And now let's run calibration again. We're still all zeros, so okay, I guess it was not needed to do that. Anyway, I'll apply that. So 2.0 Mahoney KP. We'll write it. Now remember, I did set in, so let's go back to the balance app. And in the balance app, if you remember, I set my P to 1. So I'll keep that for now. And now when I press down here, it should be really slow and smooth. What is it now? Okay, let's check. RT app, my sensors are working, that is good. Other sensor is also working. You can see the numbers go from 0 to 3.1 as soon as I touch it, so that's really good. Alright, why is it not moving? I had to end this right here. This was turning into a total shit show. First I swapped my connectors in the controller box, then I didn't tighten the bolts, thinking that something was wrong with the motor configuration. Then I also realized I loaded the wrong motor configuration from the float wheel hub, not from my XR hub. And then last not least, Imu Calibration didn't want to cooperate at all. Every time I did it, I got zeros, and that's why it didn't want to engage. It thought it was upside down. And I had to basically tune the IMU, I had to calibrate it manually, which is a long and boring process. I didn't want to film that. Well, I did film it and I ran out of battery. So long story short, I'll have to do that some other time. I did end up getting it to work. The board works just like my other board. Everything behaves as expected. The only disappointment is that I was not able to just load the VESCmann settings and get it to behave the way it behaves for harness. I'll have to look into that some more. But yeah, basically this board behaves just like my other board. It has these same problems with the VESCmann settings. I don't know what that is. I really don't know what the secret is to getting those settings to work on a new VESC board. This is it for today. Video is already long enough, so I'll just continue in the next one. See you guys.